Okay, we're going to look at the last question here. Um, we've got this parabola, we've got this exponential equation, and look what they ask us at the end. They say there's a new function h of x. What we want to do is take g of x, and we want you to add 8 to it. We want you to add 8 to it. Well, I think you get a mark just for doing that. So take the minus 8, add 8, you'll get y equals 3x. Well, there's the first part. That's the starting point. But then they say they want you to write down the inverse of that function. Well, the inverse means we switch x and y. So we switch x and y, we get x equals 3y, and then we have to use our idea of logs to know that y is really a log, and that is the base of the log. So the log of x to base 3 is equal to y. So the y is the log. There's the base. The log of x to base 3 is y. So there it is, the inverse of h. There's h, the inverse of it in the form y equals. Now they ask us, this next question is a little bit tricky. They say, what if we took f of x and we added 1 to it? Well, minus 9 would turn into minus 10, rather, if we added 1 to it, would turn into minus 9. So you'd have p of x equals 2x squared plus 3x minus 9. That's our new function. But then they ask us this question. They say, for which values of x would, when we multiply x times the function, when would it be less than 0? Well, in order to do that, um, the original function had x-intercepts of a and b. We need to find the x-intercepts because that's where it changes. You know, when you go to the right of b here, it's positive, and when you go to the left, it's negative. To even begin to answer this question, which takes some thinking, we're going to have to find the x-intercepts. So what we do is we let p of x equal 0. Then we factor it. 2x times 2x is 2x squared, minus 3 times plus 3 is minus 9, plus 6x minus 3x. There it is factored. Okay, so we get x is equal to 3 halves, or x equals minus 3. Now, this parabola that would get pushed up 1. It would be hitting at these places, at 3 halves, and at minus 3 and 0. Now it's time for us to see and try and use, I like to take a vertical line. And what I do is I'll pretend that B prime is right there. Now, to the right of B prime, it's positive, but to the left of B prime, F is negative. But X is positive all the way along here. But this would be a positive times a positive, but we want it to be less than 0. So it starts working right when x gets a little bit less than 3 halves. Then x is positive, and f of x, the parabola, would be negative. I'm using this one here. It actually is the one that's pushed up. But those would be our values, 3 halves and minus 3. Now look, everything's working here. Positive, negative, until I get to x is 0. Now it won't be negative. It'll just be nothing. So I've got to stop there. That's why my first answer is x is less than 3 halves, but greater than 0. Now I go a little bit over here, and now x is negative, but the parabola is negative down here too. So they're both negative, both negative, both. As soon as I hit this point, and it's where it's minus 3, a little bit to the left of minus 3, just a little bit to the left of minus 3, it becomes positive again. You see that y is positive, and x is negative down here, you see. These two are both negative on this side, but now one's positive, f is positive, and x is negative. And if we multiply them together, we'll get a negative number. So it works. If x is less than minus 3, then it satisfies this condition. So those are your two answers. X is less than minus 3, or x is less than 3 halves but greater than 0. And the way I do it is I take a little vertical line and I stop and I go, oh yeah, positive, but x is negative. Positive times a negative is less than 0. and I test it all the way around. Oh, it's not working here, not working. Oh, now it's working, it's working. Oh, it's not working. Okay, so that's how you do it.